In this study, we examined the effects that prediction correction can have on the accuracy of endpoint cursor prediction. Endpoint cursor prediction attempts to predict the final destination target of a user's pointing motion based on information gathered from only an early fraction of the motion. The reason endpoint prediction is worth studying is because it is one of the ways in which we can beat Fitts' law and lower the movement time needed for targeting, leading to greater user productivity. In the classical Fitts' law equation shown here, if we can correctly predict the endpoint of a pointing gesture based only on an early fraction of the gesture, we are reducing the effective value of the distance variable and lowering the movement time. One way to do this is by making predictions based on an experimentally determined kinematic model of the characteristics of pointing motions. The model used here is from a paper published in 1984 by Neville Hogan based on voluntary pointing motions in primates. The basic idea, as put forth by Edward Lank of the University of Waterloo, is to use this model of the properties of real-world pointing motions to make predictions about the motion and ultimate endpoint of the cursor in virtual space. Continuous cursor prediction uses a Newtonian equation to estimate the position of the cursor at some constant future time. This kind of technique can be very useful in groupware and other shared online applications, but it does not address the problem of endpoint prediction. Let's consider our kinematic model again. Based on the measured characteristics of the cursor motion in virtual space, we should be able to estimate where we are in the model's curves of position, velocity, and acceleration, and thus predict the position in virtual space that corresponds to the final value of position in our model. Instead of making predictions constantly like we do with continuous prediction, we want to enforce a one-to-one relationship between complete pointing gestures and predictions, such that there is only one predicted endpoint per targeting motion. I call this discrete prediction. The greatest reason we don't see endpoint prediction use often, if at all, is because it is woefully inaccurate, typically less than 50% accurate in a single dimension. Rather than attempt to determine a superior model or set of equations to improve the accuracy of endpoint prediction, I instead focused on restricting the domain of what we can mean by endpoints. It can be argued that a significant portion, even a majority of our interactions with our system that involve pointing are not characterized by us pointing at some arbitrary point in virtual space, but by pointing at a discrete interactive component of the software, like a button or a menu option or an icon. My question is this: if we define a set of possible endpoints, each one corresponding to an interactive component like a widget, and interpret the results of our vanilla endpoint prediction in terms of those possible endpoints, how much can we improve the poor accuracy of endpoint prediction? In this study, I make the assumption that the user's intended target is a previously defined possible endpoint that is closest to the result of the vanilla prediction algorithm. This has the effect of dividing the virtual space up into two-dimensional areas corresponding to each possible endpoint. The size of the area depends on the proximity of the other possible endpoints, so that the benefit of prediction correction varies inversely with the density of the interface. So how much more accurate is endpoint prediction with prediction correction? In this study, we compared users selecting targets without any kind of prediction, with endpoint prediction alone, and with endpoint prediction tempered by prediction correction. We found that on average, and in multiple interfaces of varying density, users were more than 3 times more likely to make a targeting error when using endpoint prediction without the help of prediction correction. Despite this promising result, even with prediction correction, users were much more accurate without using any kind of endpoint prediction. Users were about 31 times more likely to make an error with vanilla endpoint prediction than normal mouse pointing, and with prediction correction, users were still 9 times more likely to make a targeting error than with normal mouse pointing. Let's not forget the reason endpoint prediction is potentially valuable is because it represents one way of improving user productivity by effectively beating Fitts' law. We found that the minimum targeting times recorded by our testing were achieved with endpoint prediction, reinforcing our mathematical intuition that beating Fitts' law is possible. But when the time taken to correct errors made by endpoint prediction was considered, endpoint prediction without prediction correction was almost 3 times as slow as normal targeting, and endpoint prediction with prediction correction was almost twice as slow as normal targeting.